Today we are going to see about cloud infrastructure. That means how cloud platforms like OpenNebula and OpenStack work behind the scenes to create and manage virtual machines. In this presentation, we will cover how virtual machines are created in OpenNebula, how virtual machines are created in OpenStack, and how running systems are managed, and performance comparisons like memory, CPU, and network, and data protection methods, and also includes key differences between the architectures. Here, um, we have OpenNebula and OpenStack. This slide explains how OpenNebula creates a virtual machine from user request to resource allocation and execution. VM Lifestyle Management Overview. This includes provisioning, operation, and decommissioning, where these are the three core phases for the management overview. VM Lifestyle Stages from creation to termination. This includes virtual machines can be moved between servers for load balancing and maintenance. So, this includes create, configure, run, and terminate. Create includes the instantiate VM from template with defined resources and configurations, and configure set networking, storage, and security parameters, and then run active state with monitoring, scaling, and live migration. Terminate grateful shutdown with resource cleanup and deallocation. Here, template-based deployment, Sunstone web interface, and CLI tools and API integrations are included. This includes in the OpenNebula VM creation process. This also includes OpenStack VM creation process, which includes the Nova Compute Service, flavor selection, and glance image service, and horizon dashboard. Here, more configuration options in OpenStack is about 40%, and it is more than the OpenNebula, where OpenNebula has 15%. Running state management. This slide explains how VMs are started, stopped, passed, and monitored during the operation. Here, this includes monitoring, scaling, load balancing, and health checks. VM migration capabilities. This shows how virtual machines can be moved between servers for load balancing and maintenance. This includes live migration support, storage migration options, and cross-host movement. And then we have a performance metric comparison. This compares performance using memory efficiency and CPU utilization and network throughput. These are the performance metrics of OpenNebula and OpenStack. And we have a data protection. This explains how data is protected using backups, encryption, and access control. This includes snapshot creation, backup scheduling, and recovery procedures. Here to secure the data, we will use the encryption of data. And then scalability analysis. Here, this includes the deployment scale comparison. OpenNebula excels at edge computing with lightweight deployments, scaling to thousands of distributed nodes. So OpenStack targets enterprise scales with massive centralized deployments, supporting millions of VMs across data centers. And then we have the key architectural differences. First, we have architectural complexity, and then we have learning curve, and then community support. Here, architecture complexity includes the OpenNebula uses a monolithic, streamlined architecture, while OpenStack employs a modular, multi-service design with greater complexity. Here, OpenStack have a greater complexity architecture. And then learning curve. OpenNebula offers faster deployment and easier administration, OpenStack requires more expertise but provides deeper customization. And then community support. OpenStack has larger enterprise backing and extensive documentation. OpenNebula has focused community with response support. Thank you.